Hello guys, welcome back to this channel. In this video, we are going to discuss GATE 2024 Linear Algebra problem number 13 and its complete solution. After that, we will see what are the core concepts that are involved behind the problem. And at last, I have attached some few practice problems for you to try yourself having similar concept as that this GATE problem. Okay, so let's begin. So the problem is, consider the matrix M, which is a 2 cross 2 matrix. We need to find out which of the following statements is true. First one is the eigenvalues of M are non-negative and real. Second is the eigenvalues of M are complex conjugate pairs. Third is one eigenvalue of M is positive and real and another eigenvalue of M is 0. Fourth one is one eigenvalue of M is non-negative and real and another eigenvalue of M is negative and real. Okay, so for finding the eigenvalue of M, we need to find the characteristic equation, and solving the characteristic equation we'll get what are the eigenvalues of M. Okay, so what we have is we have M is a 2 cross 2 matrix. Now we need to find the eigenvalues of M. So for finding eigenvalues, we need to solve the characteristic equation, which is determinant of M minus lambda I. Okay, if we find determinant of M minus lambda I, then we'll get determinant of this. Okay, by solving this, what we get? We get lambda square minus 3 lambda plus 5 is equal to 0. And by solving this, we get the eigenvalues of matrix M are this, which is 3 plus root 11 I by 2 and 3 minus root 11 I by 2. Okay, so which means the eigenvalues of M are complex conjugate pairs. Okay, because if plus exists, then minus is also exists. Okay, which means the eigenvalue are complex conjugate pairs. So the correct statement is the eigenvalues of M are non-negative and real. This is wrong. The eigenvalues of M are complex conjugate pair. This is correct. One eigenvalue of M is positive and real. This is also wrong. One eigenvalue of M is non-negative and real. This is also wrong. So the correct option is B. Now moving on to the core concepts that are involved behind our problem. So let A be a matrix. We are 2 cross 2 matrix, which entries are A, B, C and D. Then we know that the characteristic equation of A, which is the determinant of A minus lambda I. Okay, this is the characteristic equation. If we solve this, we will get lambda square minus A plus D lambda plus AD minus BC. Okay, so if we see this, if we carefully notice this, we can write the characteristic equation of a 2 cross 2 matrix as lambda square minus trace into lambda plus determinant. How? If we see the trace of this matrix, this is A plus D and determinant is AD minus BC. So lambda square minus trace into lambda plus determinant in. Okay, so this is the shortcut for writing a characteristic equation of a 2 cross 2 matrix. Second one is, if the matrix A has only real valued entries, then any complex eigenvalue must appear along with its complex conjugate, which means if A is a real matrix, okay, let's say if A is a real matrix of n cross n, and if complex eigenvalue exists, if lambda belongs to C, then this complex eigenvalue must occur in a complex conjugate pair. What does that mean is, that mean if one of the eigenvalue is, let's say 2 plus 3i, then 2 minus 3i will also be an eigenvalue of given matrix. Okay, third one is, for a complex matrix, eigenvalue do not have to appear in complex conjugate pair. Okay, if the matrix is complex, that is A belong to C of n cross n, okay, then the eigenvalue need not to be occur in complex conjugate pair. Okay, so now moving on to few practice problems that is similar to the above problem. So the first problem is, given matrix B, which is a 3 cross 3 matrix, we need to find all the correct options. First is eigenvalues are 2 comma 2 comma 2, eigenvalues are 2 comma 2 comma minus 2, eigenvalue 2 has algebraic multiplicity of 2, B is positive semi-definite. Okay, so for finding eigenvalues of b, first we need to find the roots of the characteristic equation, that is determinant of b minus lambda I is 0. If we find the roots, then we can find the eigenvalues of b. Okay, by solving this characteristic equation, here it should be b, where we get that the eigenvalues of b are 2 comma 2 comma minus 2. Okay, so this is wrong, this is correct. Eigenvalue 2 has algebraic multiplicity of 2. Since the eigenvalues of b is this, okay, and 2 eigenvalue repeated twice, which means algebraic multiplicity of 2 is 2. So eigenvalue 2 has algebraic multiplicity of 2. This is also correct. Now the last one is b is positive semi-definite. We need to find whether x transpose bx is always greater than is greater than or is equal to 0 or not. Okay, so PSD matrix has this one property, that is if the matrix is positive semi-definite, then all the eigenvalues of PSD matrix is always greater than or equal to 0. Okay, if we go by this property, then we carefully notice that one of the eigenvalue of b is negative. Okay, which means b cannot be a positive semi-definite matrix, which means this option is incorrect. Now moving on to the practice problem 2, which is a given matrix C, which is a 4 cross 4 matrix. Which of the following statements is true? First one is eigenvalues are 2 comma 2 comma minus 2 comma minus 2. Eigenvalues are 2 comma minus 2 0 comma 0. 1 1 1 1 transpose is an eigenvector and C is diagonalizable. Okay, so for finding the eigenvalues, either what we can do, we can find the characteristic equation, that is determinant of C minus lambda I, make it 0, we can get lambda. Okay, but one shortcut for this is, since the sum of each row is 2, sum of each row is same and 2, which means that 1 comma 1 comma 1 comma 1, this is an eigenvector of C corresponding to eigenvalue, which is sum of each row 2. Okay, so since sum of all rows are same, and hence eigenvalue is equal to sum of each row, that is 2, and corresponding to eigenvector 1 1 1 1 transpose. Okay, which means this is an eigenvector of given matrix C. Now since if we carefully see, row 1 and row 3 are same, row 2 and row 4 are same. Okay, which means if we find out the rank of C is equal to 2 and nullity is equal to rank dimension minus rank, okay, that is 4 minus 2 is equal to 2. Since rank is equal to 2, nullity is equal to 2 and dimension is equal to 4, which means two of the eigenvalues of C are 0 and two of the eigenvalues are non-zero. Okay, one eigenvalue we know, one eigenvalue is 2, two eigenvalues are 0 comma 0. Okay, and we know that sum of diagonal elements is equal to sum of eigenvalues. Okay, so sum of diagonal elements, if we see, these all are 0, so sum of eigenvalues 2 plus 0 plus 0 plus, let's say lambda, is equal to 0, and one of the eigenvalue will be minus 2. So the eigenvalues are 2 comma minus 2 comma 0 comma 0. Okay, so this is correct, this is also correct, this is wrong. Now C is diagonalizable. Last option is, if we carefully look C, so C is a symmetric matrix. C is a real symmetric matrix. Okay, C is a real symmetric matrix, and we know that one of the beautiful property of real symmetric matrix is always diagonalizable. Okay, real symmetric matrix is always diagonalizable, which means C is also diagonalizable. Okay, I have this is some hint which you can find out helpful in solving the problem. So thank you. If you have any doubt, you can let us know in the comment, and for more such videos, don't forget to subscribe. See you in the next video. Thank you.